Greetings, everybody. So I'm here to show you this problem from our assignment that involves the chain rule. What makes this problem a little bit unique, I think, is that one of the functions given in our situation is unknown. Okay, it's not completely specified. I know that if you plug in 4 to that function, you get out -6. And if you plug in 4 to the derivative of that function, you get out 8. But I don't know what the function is. Okay. All right, so here is the situation, which I've already summarized a little bit for you. I have f of x being some unknown function. I know f of 4 and f prime of 4. And then I have this other function g of x, which is sine of pi times f of x being the unknown function. So that's what I have. That's the scenario. And what I want is g prime of 4. What's that? That's the question. So what I'll notice about this is that g of x is a composition of functions, meaning it's one function inside of another. How many functions do you see here? Well, there's the sine function, and then there's this other function that's unknown called f of x. And it's a composition because the f of x is inside the sine. And what I mean by that is if I were to calculate this, I'd have to follow the order of operations of calculate f of x, multiply by pi, then find sine of whatever that number is. So there's that order of operations where I have to calculate this inside part first and then do sine. That's what makes it a composition. Okay, so because that's a composition of functions, there's a rule in calculus that we use to find the derivative of a composition function, and that's called the chain rule. So here's the chain rule as I see it being applicable to this case. Okay, the general chain rule goes like this. If I want the derivative with respect to x of a composition g of f of x, where the f of x is inside the g, then that derivative is g prime of f of x times f prime x. Okay, now that's just in general. That's for anything. Like this g here could be anything. It could be the sine function. It could be the square root, or it could be the 11th power, or whatever. Okay. If I adapt this to apply particularly to the sine function, then here it is. The derivative with respect to x of sine of f of x will be, okay, what's the derivative of sine? Cosine of f of x, then times f prime x. So do you see how this is the general rule, and then I've adapted it to our situation? Okay, so here goes. Here's how you find g prime of x. I'll find g prime of x, and then I'll plug in 4 in particular for the x. I'll get my answer that way. So the derivative with respect to x of sine of pi times f of x is, okay, let's look at our rule. Cosine of this interior function, pi times f of x, times, all right, what's the derivative of pi times f of x? What's the derivative of that inside function right there? Okay, I know it might be confusing that I have to write my notation in a way that resembles this problem maybe a little too much. You know, here I wrote that there's a function inside sine. And that's what I have here, but it's also pi times a function. But nonetheless, that entire thing, pi times f of x, is what's inside there. So right here, I've got to write the derivative of what pi times f of x is. Well, pi is a constant, so the derivative of pi times f of x is, by the rules of calculus, pi times f prime of x. Okay, so there it is. There's your g prime of x. Now, you have that. You can calculate g prime of 4 when x is 4, or anything else, all right, so long as you have the information. So let's see. G prime of 4, I'll put 4 in for x, where I see it. It's cosine of pi times f of 4 times pi times f prime 4. All right, that's just this with x being 4. And if I wasn't given some additional information, I would be stuck here. Like, what's f of 4? Like, unless you tell me, I don't know. Like, I wasn't It wasn't revealed what f of x was. So how can I find f of 4? What's f prime of 4? Same thing. F of x and f prime are unknown. But I was given that, in particular, f of 4 and f prime of 4 are negative 6 and 8. So I use that, right? Now, where you got that, I don't know. Doesn't say, but that's the data we have. Okay, sometimes we don't have a function. We just have data from a laboratory. All right, somebody does an experiment, they make measurements, they say, I don't know what this function is here, but I know that these are the measured values that we would get. Okay, so maybe it's kind of like that. All right, so in that case, this turns out to be cosine of negative 6 pi times 8. Cosine of negative 6 pi is 1, so that turns out to be 8 pi. 8 pi is our answer. There you go. Now, this is abstract, and what I mean is, because I don't know what f of x is, I have to think in very general terms about how the chain rule is applied. But maybe an analogy would help you. I think this situation is exactly like this one. Finding the derivative of sine of pi x squared. It's just like that. Maybe if you saw this analogy, it would help you see how the chain rule is applicable to this right here. So I'll use our rule. I'll use the chain rule. If y is sine of pi times x squared, then the derivative of that is cosine of pi times x squared times the derivative of pi times x squared. Well, pi is a constant. The derivative of pi times x squared is pi times 2x. All right, that's the rule there. That's what it would look like if I know what that inside function is right there, just by analogy. Okay? By comparison, I didn't know it over here, but the rule unfolds the same way. I could move my terms around and I'd say, well, okay, I've got a coefficient of 2 pi x and cosine pi x squared. So that's my analogy. I hope even if my explanation of the chain rule was a little bit vague here, that you can see by this analogy exactly how it applied.